Welcome to the series of e-learning modules on practicals. In this module, we shall stimulate the random samples from the given distribution. We can also compare the mean and variance of theoretical and sample distributions. By the end of this session, you will be able to stimulate observations from a given distribution, compare the mean and variance of an original distribution with the stimulated distribution. In the first exercise, we are required to stimulate a random sample of size 10 from a discrete uniform distribution with parameter n is equal to 5 using the random numbers given, which are 614, 122, 811, 658, 147, 389, 948, 825, 994, 862. Also, we are required to compare sample mean and variance with the population measures. Given X follows discrete uniform distribution with parameter n is equal to 5. Therefore, the probability mass function is given by P of X is equal to 1 by n, where X take values 0, 1, 2, 3 and 4, which is equal to 1 by 5. To stimulate the random sample, first we complete the table as given. The first column in the table denotes the values taken by X, that is 0, 1, 2, 3 and 4. The second column denotes the probability of X, which takes the value X, which is calculated using probability mass function. Since P of X is independent of X, all the P of X is equal to 1 by n is equal to 1 by 5, which is equal to 0.2. The third column gives the probability that X is less than or equal to X, that is the cumulative probabilities. First we write the value of P of X as it is. In the next row, we add this probability to the probability of P of X, that is 0.2 plus 0.2 is equal to 0.4. The third row will be 0.4 plus 0.2 is equal to 0.6 and so on. Usually, the last entry in this column will be 1, since the total probability of any probability mass function is 1. Now, using the cumulative probabilities, we write range for the random numbers. Since we have given 3-digit random numbers, we write 3 digits in the range. Usually, while writing the range, lower limit of probability is included in the same class and the upper limit in the next class. That is, first cumulative frequency we have 0.2. If we consider 3 digits after point, we get 0.200. Hence, first range we write as 000 to 199. 200 is then included in the next class, that is 200 to 399, etc., till the last class, which will be 800 to 999. Once we have filled in the range column, we put tally bars using the given random numbers. The first random number is 614, which belongs to the fourth row in the table. Hence, we put the tally bar in the fourth row, that is X is equal to 3. Second random number is 122, which belongs to the first row, that is X is equal to 0. Hence, we put tally bar in the first row. Likewise, we put tally bars using all the random numbers. Hence, the random observations from discrete uniform distribution is given by 3, 0, 4, 3, 0, 1, 4, 4, 4, 4. The sixth column gives the frequencies of the values taken by X. We count the number of tally bars in the fifth column and write the frequencies. Since we need to calculate the sample mean and variance, we calculate two more columns, f into x and f into x square, and find the totals of f, f into x and f into x square. First, let us find the population mean and variance. For a discrete uniform distribution, mean is equal to n minus 1 by 2 is equal to 5 minus 1 divided by 2 is equal to 2. And variance is given by n square minus 1 divided by 12 is equal to 5 square minus 1 divided by 12 is equal to 2. From the sample observations, the sample mean is given by x bar is equal to summation of f into x by n is equal to 27 by 10 is equal to 2.7, and variance is given by sigma square is equal to summation of f into x square divided by n minus summation of f into x divided by n the whole square, which is equal to 99 by 10 minus 27 by 10 the whole square, again equal to 2.61. Here, observe that the sample mean and variance are greater than that of population mean and variance. In this exercise, we need to stimulate a random sample of size 10 from Bernoulli distribution with parameter p is equal to 0.4 using the random numbers 845, 449, 339, 797, 345, 937, 573, 194, 476 and 968. Also, we need to compare the sample mean and variance with population measures. Given that x follows Bernoulli distribution with parameter p is equal to 0.4, therefore, the probability mass function p of x is equal to p power x into q power 1 minus x, where x takes the value 0 and 1, is equal to 0.4 power x into 0.6 power 1 minus x. To stimulate the random numbers, first we create the table. Here x takes only two values, 0 and 1. Using p of x, we find the corresponding probabilities, and in the next column, we find the cumulative probabilities. Using the cumulative probabilities, we find range to put tally bars to the given random numbers so that we can stimulate the random observations. The first random number corresponds to x is equal to 1. The second random number corresponds to x is equal to 0, and so on. We can stimulate 10 random observations from Bernoulli distributions as 1, 0, 0, 1, 0, 1, 0, 0, 0, 1. To compare the population mean and variance with sample mean and variance, we calculate three more columns, f, f into x and f into x square, and find the corresponding totals. Now let us find the population mean and variance. Population mean is given by p is equal to 0.4 and variance is equal to p into q is equal to 0.4 into 0.6 is equal to 0.24. For the sample, mean is given by x bar is equal to summation of f into x divided by n is equal to 4 by 10 is equal to 0.4. Variance is given by sigma square is equal to summation of f into x square by n minus summation of f into x divided n the whole square is equal to 4 by 10 minus 4 by 10 whole square is equal to 0.24. Here we need to note that in this distribution for given random numbers, the sample mean and variance exactly coincide with population mean and variance. In this exercise, we need to stimulate a random sample of size 15 from binomial distribution with parameters n is equal to 5 and p is equal to 0.5 using the random numbers given 443, 207, 761, 503, 575, 227, 222, 108, 489, 255, 877, 182, 190, 380, 758. Also, we need to compare the sample mean and variance with population measures. Given that X follows binomial distribution with parameters n is equal to 5 and p is equal to 0.5. Therefore, probability mass function is given by P of x is equal to ncx into p power x into q power n minus x, where x takes the values 0, 1, 2 and so on to n. That is, P of x is equal to 5cx into 0.5 to the power 5. To stimulate the random observations from binomial distribution, first we find the following table. Here, x take values 0, 1, 2, 3, 4 and 5. Using the probability mass function of binomial distribution, we find P of x. Then we find the cumulative frequencies as we have done in the earlier problems and fill in the ranges as 0, 0, 0 to 030, 031 to 186, etc. and lastly 969 to 999. Now, using the random numbers given in the problem, we can generate random observations from the binomial distribution as 2, 2, 3, 3, 3, 2, 2, 1, 2, 2, 4, 1, 2, 2 and 3. To compare the population mean and variance with sample mean and variance, we calculate 3 more columns f, f into x and f into x square and find the corresponding totals. Now let us find the population mean and variance. Mean of the binomial distribution is given by n into p is equal to 5 into 0.5 is equal to 2.5. And variance is n into p into q is equal to 5 into 0.5 into 0.5 is equal to 1.25. Next, the sample mean and variance are found as follows. Sample mean is given by x bar is equal to summation of f into x divided by n is equal to 34 by 15 is equal to 2.2667 and variance sigma square is equal to summation of f into x square divided by n minus summation of f into x by n the whole square. Observe that in this problem, mean of the population is greater than that of sample mean and variance of population is greater than that of variance of sample. Stimulate a random sample of size 15 from binomial distribution with parameters n is equal to 6 and p is equal to 0.3 using following random numbers 4462, 6791, 6102, 0215, 7398, 2671, 6175, 0513, 1413, 8771, 1596, 1747, 2005, 2493 and 9285. Given x follows binomial distribution with parameters n is equal to 6 and p is equal to 0.3. Therefore, probability mass function is given by P of x is equal to ncx into p to the power x into q to the power n minus x, where x takes the values 0, 1, etc. to n. Substituting the values in the equation, we have P of x is equal to 6cx into 0.3 to the power x into 0.7 to the power 6 minus x. Before we stimulate the random observations, first we find the following table. Here x take values 0, 1, 2, etc. to 6. By substituting the values of x in P of x, we can find the second column P of x is equal to x. Third column gives the cumulative probabilities, and using these probabilities, we write the fourth column, which is nothing but the range for random numbers. Since we have been given the 4-digit random numbers in this problem, we write 4 digits for the range of the random numbers. That is 00002, 1175, 1176 to 4200 and so on. Now using the random numbers given in the problem, we can generate random observations from the binomial distribution as 2, 2, 3, 3, 3, 2, 2, 1, 2, 2, 4, 1, 2, 2 and 3. In this exercise, we are required to stimulate a random sample of size 15 from Poisson distribution with parameter lambda is equal to 0.25 using the following random numbers: 230, 298, 864, 891, 498, 462, 635, 618, 214, 939, 601, 832, 158, 635 and 984. Given that x follows Poisson distribution with parameter lambda is equal to 0.25. Therefore, the probability mass function is given by P of x is equal to e power minus lambda into lambda power x by x factorial, which is equal to e power minus 0.25 into 0.25 to the power x divided by x factorial, where x takes the values 0, 1, 2, etc. to infinity. To stimulate the random observations, first we find the following table. Since we do not know the last value of x, we find P of x is equal to x and the cumulative probabilities simultaneously. Observe that since lambda is small, we get very large probabilities in the beginning. We reach cumulative probability 0.998 when x is equal to 2, and hence the remaining probability 0.0002 by putting x greater than or equal to 3, and we get the last entry in the third column as 1. Since we have given only 3-digit random numbers, we write 3 digits in range column. Once we have the range column ready, we can generate the random observations from Poisson distribution as 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0 and 2. Stimulate a random sample of size 25 from Poisson distribution with parameter lambda is equal to 5 using following random numbers: 633, 570, 128, 966, 219, 045, 054, 260, 001, 042, 986, 685, 763, 564, 982, 593, 652, 003, 080, 861, 812, 679, 627, 430, 896. Given that x follows Poisson distribution with parameter lambda is equal to 5. Therefore, the probability mass function is given by P of x is equal to e power minus lambda into lambda power x by x factorial is equal to e power minus 5 into 5 power x divided by x factorial, where x takes the values 0, 1, 2, etc. to infinity. To stimulate the random observations, first we find the following table. Observe that p of x values are very small. Hence, we find probabilities of x and the cumulative probabilities simultaneously. When x is equal to 11, the cumulative probability becomes 0.994. Hence, the remaining probability, that is 1 minus 0.994, is equal to 0.006, and we assign to x value as greater than or equal to 12. Once we obtain the cumulative probabilities, we can find the range for the random numbers and stimulate random observations from the Poisson distribution. Hence, we get the random sample as 6, 5, 3, 9, 3, 2, 2, 3, 0, 2, 11, 6, 7, 5, 10, 5, 6, 1, 2, 7, 7, 6, 6, 4, and 8. Stimulate a random sample of size 15 from geometric distribution with parameter p is equal to 0.6 using following random numbers: 271, 478, 866, 828, 436, 250, 005, 939, 048, 031, 759, 124, 601, 105, and 715. Given x follows geometric distribution with parameter p is equal to 0.6, therefore the probability mass function is given by p of x is equal to q power x into p, where x takes the values 0, 1, 2, etc. and p lies between 0 and 1. This is equal to 0.4 power x into 0.6. Next, to stimulate the random observations, first we find the table as given. Here, we do not have the last value of x. Since x takes the values from 0 to infinity, we find p of x and cumulative probabilities of p of x less than or equal to x simultaneously. Observe that when x is equal to 4, we get cumulative probability as 0.989. Hence, we combine other values of x and write greater than or equal to 5, and the remaining probability we assign to this class, that is 0.011. Using these cumulative probabilities, we find the range for the random numbers and stimulate the random observations from the distribution as 0, 0, 2, 1, 0, 0, 0, 3, 0, 0, 1, 0, 1, 0, and 1. In this problem, we have to stimulate a random sample of size 15 from geometric distribution with parameter p is equal to 0.3 using the given random numbers 521, 000, 009, 209, 818, 833, 180, 161, 714, 426, 804, 510, 734, 891, and 912. Given that x follows geometric distribution with parameter p is equal to 0.3, therefore the probability mass function is given by p of x is equal to q to the power x into p, where x takes the values 0, 1, 2, etc. and p lies between 0 and 1, is equal to 0.7 to the power x into 0.3. To stimulate the random observations, first we find the following table. Like in the previous problem, here too we do not have the last value of x. Since x takes the values from 0 to infinity, we find p of x and cumulative probabilities P of x less than or equal to x simultaneously. Observe that our highest random number here is 912, which corresponds to x is equal to 7. Hence, we can write the table either up to x is equal to 7 or 8. Thus, we stop the table by writing greater than or equal to 8. The next column gives the range for random numbers, using which we generate the random observations for the following distribution as 2, 0, 0, 0, 4, 5, 1, 1, 3, 1, 4, 2, 3, 6 and 6. Stimulate a random sample of size 20 from negative binomial distribution with parameters r is equal to and p is equal to 0.75 based on the following random numbers: 989, 761, 511, 755, 386, 894, 565, 999, 979, 525, 083, 912, 994, 865, 915, 052, 208, 785, 073, 690. Given that x follows a negative binomial distribution with parameters r is equal to 5 and p is equal to 0.75. Hence, the probability mass function is given by P of x is equal to x plus r minus 1 c r minus 1 into p to the power r into q to the power x, which is equal to x plus 4c4 into 0.75 to the power 5 into 0.25 to the power x, where x takes the values 0, 1, 2, etc. and p lies between 0 and 1. Now, to stimulate the random observations, first we find the following table. As we have done in earlier problems, here also we give find p of x for different values of x and write it in the second column, and find the cumulative probabilities in the third column. Next, using cumulative probabilities, we write the range for random numbers to generate random observations from the distribution. Hence, the random observations are given by 6, 3, 1, 2, 2, 4, 2, 9, 5, 1, 0, 4, 7, 3, 4, 0, 0, 3, 0 and 2. Here's a summary of our learning from this session. Stimulate observations from any given distribution. Compare the mean and variance of the original distribution with the stimulated distribution.